Hey guys, Dr. Brown here, and tonight we're looking at the integral of 1 plus natural log x over x cubed dx. Okay, looks like a good U sub. You know our tools: U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and method of quadratics. 1, 2, 3, 4, 5, 6, 7, 8 tools. Okay, and tonight I think I'm going to start with U sub. So let's let U equal natural log of x. Okay, matter of fact, let's just scoop that over because we're going to need the room. U equals natural log of x. So du equals 1 over x dx. Okay, we need to solve for dx because we need to substitute for that. So x du equals dx. All right, let's fill in the blanks here. We have the integral of 1 plus u over x cubed, and then dx is x du. So one of these x's cancel, so I end up with x squared on the bottom. So 1 plus u du over x squared. Hey, we're trying to go to the u world. I don't need an x term. So how can I solve for x? Well, if u equals natural log of x, e to the u equals e to the natural log of x, which is x. Awesome. But I need x squared. So I have e to the u squared equals x squared. Now you know a to the m raised to the n is a to the m times n. So this would be e to the 2u. So x squared equals e to the 2u. So let's just pull that guy to the numerator. So I have 1 plus u e to the minus 2u du. Okay, I erased all of our tools, but now it looks like integration by parts, right? Okay, using maybe the DI method. Let's try that guy. Plus, minus, plus, minus. Let's see, we can integrate e to the minus 2u. That would be easy, and 1 plus u. We can differentiate that relatively easy. So the derivative of 1 plus u, the derivative of 1 is 0. Derivative of u would be 1 du. And if we do that again, we get 0. All right, so the integral of e to the minus 2u, the integral of e to the u du. So if, let's see, t equals minus 2u, then I would have dt equals minus 2 du, or dt over minus 2 equals du. So this would end up being minus 1/2 e to the minus 2u. And if I integrate that again, I get a negative 1/2 times negative 1/2, which would give me a positive 1/4 e to the minus 2u. Okay, so we multiply those diagonals. And what do we end up with? We end up with all of this integral here equals a negative 1/2 times 1 plus u, negative 1/2. So negative and positive, we've got this negative. Negative 1/2 times 1 plus u e to the minus 2u minus 1/4 e to the minus 2u. Now we could put those into the denominator. Matter of fact, I think I'll just do that here. 2e to the 2u this would be minus 1 over 4e to the 2u. Okay? So I'll take that 1 off. All right, so we have minus 1 plus u over 2e to the 2u minus 1 over 4e to the 2u. Well, what was e to the 2u? That's x squared. I could change that to x squared. That's x squared. But I need to get a common denominator, so I need to multiply this guy by 2 over 2. So now everything is over 4x squared. So I have negative 2. I'm going to distribute that to the inside. Negative 2 times 1 gives me negative 2 minus 2u minus 1. So negative 2 minus 1 gives me a negative 3 minus 2u over 4x squared. And what was u? U was natural log of x plus c. Now I could factor out that negative and look at it like that. So negative, the parentheses of 3 plus 2 natural log x over 4x squared plus c. And that, my friend, is the integral of 1 plus natural log x over x cubed. Now you can see, matter of fact, I started this when I worked it the first time, I said, u sub. I'll let u be 1 plus natural log x. That was the wrong thing to do. I didn't, it's, you could cancel an x, but what am I going to do? This integral would have been totally different. So it added a level of complication into it that I didn't need. So I backed up, said, wait a minute, let me just let u equal natural log x, and then that made a much easier solution. Why are we doing this? Together, we're trying to build a better tomorrow through math. Keep practicing, practicing, practicing. Okay, and I'll talk to you next time. Thanks.